All right, let's keep moving on here in chapter 11. We're going to talk about simplifying radical expressions, okay? There's actually quite a lot of material in this one, so I'm going to kind of go quickly, and if you need to, you're going to have to come back and kind of check through and look through some of these slides again, okay? Also, utilize your book to look at some of the examples. Some of the examples I'm going to do in this presentation are the ones that are in the book. A couple of them are not, so... all right, first, simplifying radicals. Here's the deal. There's 3 rules, okay? First, no fractions underneath the radical. You cannot have any radicals in the denominator. And there are no perfect squares allowed under radicals. Now, what I want you to do very quickly here is I want you to go ahead and I want you to list out the first 15 perfect squares, okay? List the first 15 perfect squares. Go ahead and do that now. So here are your 15 perfect squares, right? 1 squared is 1, 2 squared 4, 3 squared, and on and on and on and on, okay? I would highly suggest memorizing these. Make sure you know them. In fact, it might even be beneficial to you if you memorize them up to 25. But definitely the first 15. Okay, so these are perfect squares. So anytime we have these numbers, okay, these are perfect squares. Anytime these are factors underneath the radical, we're going to need to pull them out. And so let's take a look and see what that looks like, okay? The square root of 32, all right? We look back and we say, okay, let's take a look at our rules. No fractions underneath the radical, no radicals in a denominator, no perfect squares. So if we look at this, there are no radicals in the denominator, there are no fractions, so we don't have to worry about it. But this does have a perfect square in it, okay? You could look at this as being, you know that 4 is in it. I also know that 16 is in there. So what I could do is I can rewrite this as 16 times 2. Okay, now when you do this, what you can do is you can actually separate this into 2 separate radicals. I can do 16 times the square root of 2. Whoops. 16 times the square root of 2. And then what I can do is I can take the square root of 16 is 4. So this becomes 4 radical 2. Okay? So that's one way. What I also could have done is we could have said that this was the square root, and we could have said 4 times 8, right? But 8 has a perfect square in it, so that becomes 4 times 2. Okay, and then when you see this is 4 squared, so it's the square root of 4 squared times the square root of 2, and then when you simplify that, that's going to give you this same answer here, okay? 4 radical 2. Okay, that's going to be the biggest deal here. That's going to be the biggest thing, is pulling out perfect squares, okay? The other parts are, I think, a little bit easier, but finding and remembering to pull out all of the perfect squares, okay? You have to try to pull out all perfect squares when you do these. And hopefully you kind of remember doing this last year, and I know a lot of you guys kind of struggled with it, but like many things, the second time you see it around, it tends to be a little bit easier. So let's go ahead. 9x cubed. There are a couple perfect squares in here. We can break this down. This is 3. Well, 9 is a perfect square, so we can do this. Let's just say 9 times, and then I can say x squared is a perfect square, and then times x. And then what I could do is I can break this up to square root of 9 times the square root of x squared times the square root of x. Okay, so this is all one giant multiplication problem. So the square root of 9 is 3, and the square root of x squared is x, and the square root of x is just the square root of x, and so this would be my simplified answer, okay? There are no perfect squares underneath the radical, there's no radicals in the denominator, and there are no fractions underneath the radical. Okay, moving on. Let's take a look at another one. This is one when you're multiplying. So this is sort of after we've looked at this, right? We looked at ones before where we broke it down, right? We broke it down into a multiplication problem underneath the radicals, and then we split the radical apart. In this case, what we're doing is the radicals are already split. So what I want to try to do is, let's go ahead, and what I can do is, if you can split them, right, to begin with, then what you can do is you can say this is the square root of 6 times the square root of 9. Okay? It's the same idea. Well, 6 times 9 is going to be, actually, this is a bad example. This is not what I meant to do. Let's try, let me do this. Let me switch this example quickly. Oops. Hold on, sorry. Board is freaking out. I want to change this. I wanted to make this actually 12. Okay, so let's go ahead and do that real quick. All right, there we go. Okay, so what we're going to do here is we're going to say, okay, this is the square root of 6 times 12, okay? 12. And then what I can do is I can say, well, 12 is actually 6 times 6. Man, this board is being slow, sorry. 6 times 2, okay? Right? And now I have 6 squared here, so that's the square root of 6 squared times the square root of 2. So the square root of 6 squared is just 6 times the square root of 2. Okay? There's an example there. Do another one here. We got 3x times 4 times x. Now, anything underneath the radical we can multiply. Anything on the outside of the radical you can multiply. But you can only multiply things on the outside with other things on the outside, and only things underneath the radical with other things underneath the radical. Okay? So what this is going to do is this is going to become 4 times the square root of 3x times x. Okay? So that's 4 times the square root of 3x squared. Well, I know that this is the square root of 3 times the square root of x squared. Okay? And now I can take the square root of this, and I don't want to leave this at the end. You always want to put anything that's outside the radical, you want to try to put in front. So the square root of x squared is going to be x. So it's going to be 4 times x times the square root of 3. All right? There you go. There you have it. Okay, let's keep moving on here. Give a couple of examples. In fact, why don't you go ahead, why don't you pause the video and you try this one on your own. Okay, ready? Go. All right, so what you should have done, hopefully, is you would have rewritten this as 3, and we can do everything underneath this radical. So we have 7 times x is x squared times y squared. All right, then you can break this up as the square root of 7 times the square root of x squared times x squared times the square root of y squared. All right, and then you're going to get 3. Okay, this stays. This becomes x. This becomes y times the radical 7. Okay? And again, check yourself. You look at it and you say, any perfect squares underneath the radical? No. Any radicals in the denominator? No. Any fractions underneath the radical? No. All right, so let's go ahead here. Now we're looking at a couple of things here, and we look at this and we say, okay, wait a second. All right, I got a fraction underneath the radical, okay? So what you're going to do is you're going to say, okay, this is the square root of 27, and you break it apart over the square root of 100, okay? Well, the square root of 27 is going to be, does that have any perfect squares in it? Hopefully you notice that 9 is in there, so this is 9 times 3 over, and the square root of 100 is 10. Okay, well this becomes 3, so I'm going to get 3 times the square root of 3 all over 10. And then I look, can I simplify here? Do 3 and 10 have any common factors? They do not. This is my final answer. Okay. So why don't you go ahead and try the radical 7 over x squared. Try that one. All right, hopefully the first thing you did here is you said broke it up, square root of 7 over the square root of x squared. And then you look and you say, well, that's just going to say square root of 7. And the square root of x squared is x. Okay? No perfect squares underneath the radical, no radicals in the denominator, no fractions underneath the radical. All right, looking good. Well, of course, we're going to do something a little bit harder. What happens here is sometimes you have a radical in the denominator, okay? And this is where it's a little different from last year. Now what we have to do is we have to do this thing. It's called rationalizing the denominator, okay? And right now this is an irrational number in a denominator, and you can't have an irrational number in a denominator. So what we need to do is make it into a rational number. All right? Well, to do this, what we're going to do is we're going to multiply it by 1, okay? Because anytime you multiply anything by 1, you're not really changing it. But the one that we're going to use is, I'm going to multiply this times radical 7 and this times radical 7. Okay? So what you're doing is you're multiplying. This is 1, right? This fraction here is 1, but I'm going to multiply this across. So I get 5 radical 7 over the square root of 7 times 7. Well, that's going to be 5 radical 7. 5 radical 7 over 7. Okay? The square, this is radical 7 times radical 7, right? The square root of 7 times the square root of 7. That's going to be 7. Okay, because it ends up being the square root of 7 squared, or 49, and that becomes 7. Now, it looks like maybe you could simplify here, right? But remember, this 7 is you're taking the square root of it, okay? So you'd have to do this square root first before you could ever do anything with that 7. So this is your final answer, okay? Why don't you go ahead and you try this problem here. Go. All right, well, hopefully you broke it up and you said the square root of 2 over the square root of 3b, and then you look at it and you say, okay, right, well, because this is a fraction, it's in underneath the radical. So you split it up, and then you say, okay, no fractions underneath radicals. However, I have a radical in the denominator, so let's go ahead and let's rationalize the denominator. Okay? And what I'm going to get here is I'm going to get a denominator of 3b, and then I've got radical 2 times radical 3b, so I'm going to get that's going to be 2 times 3 is 6b. Okay? And I'm done. No perfect squares in the denominator, no radicals underneath no fractions underneath the radical, no radicals in the denominator, no perfect squares. Done. All right. Keep moving. Let's fly through this. All right, next. Sometimes you have to add and subtract radicals, okay? Well, first let's see if we can simplify these anything here. Radical 10, no perfect squares. Radical 13, that's prime, it's done. Radical 10, that also no perfect squares. Now, I do notice that I have this radical 10 and this radical 10. And this is where you can simplify them, okay, when you add them. Okay, I have 4 of these. 4 radical 10s, and I have -9 radical 10s. Well, if there's 4 of these and -9 of these, that means I have -5 radical 10 plus radical 13. Okay, now you cannot add these things, like this radical 10 and this radical 13. I cannot add those. I can't make that radical 23. It doesn't work that way, okay? If I was adding it underneath, right? If this and this were both underneath the radical, it would work. But this says take the square root of 10 first, take the square root of 13 first, then add them, right? And I'd have to multiply by -5. So just give you an idea, okay? That breaking up and multiplying, that works because you're multiplying, okay? And finding the square root of something is kind of a version of multiplying, okay? So let's try another one here. Why don't you go ahead and simplify this first, and then we'll see if we can add it. Go ahead. All right. Hopefully what you did is you looked at this thing and you said, okay, this can't be simplified, but look, you looked at this one, and I mean, I'm hoping you sort of look at this and say, well, I bet this is going to end up being radical 3, right? So what times 3 would be 48, and you'd see that would be 16. But let's say you didn't get to that point and you looked at this and you said, okay, well, I know 4 goes into that, right? So it's 4 times 12, right? But then what I'm hoping you see is there's another 4 in there. So you get 4 radical 3. Whoops. This thing is being slow. 3 plus 2 radical 4 times 4 times 3. Okay, and so that means 4 radical 3 plus, okay, now what's going to happen here is we have 4 squared. So the square root of 4 squared is 4. That's coming out, multiplied by 2, so I get 8 radical 3. Okay. Now I'm going to take my two, I have 4 of these radical things, right, and 8 of these things, and this thing and this thing are the same, right? Square root of 3, square root of 3, I have 4 of them, and I have 8 of them, so altogether I have 12 of them. Cool. All right. Let's try another one. All right, this is when we start multiplying radicals, okay? So this will be one where we take this and we say, okay, let's we're going to use distributive property, okay? Same rules apply, just because the radicals doesn't matter. So this is going to be 4 radical 5 minus radical 5 times radical 20, So I get 4 radical 5 minus, all right, and what I can do here is 5 times 20 is 100, when the square root of that is 10. So we're going to get 4 radical 5 minus 10. Now, typically when we do these, a lot of times we like to keep the the constant terms in front. So if we want to do something like this, we can go ahead and we can just write it as negative 10 plus 4 radical 5. Okay, so that's another way you can write it. A lot of times they just like to have those things in the front like that. So, but either one of these is fine, really. Okay, let's say the same thing. All right, let's go ahead and take a look at another one. Why don't you go ahead and look at this? Okay, now think of this. It's kind of like a binomial. So go ahead and try solving it. Okay, so let's do this. We're going to do 4 times 1, and we get 4. And we'll do 4 times negative radical 5, so we're going to get minus 4 radical 5. And we get negative radical 5 times 1, so it's going to be minus radical 5. And then negative radical 5 times negative radical 5, right? So that's going to basically be plus radical 5 times radical 5. So I get 4 minus, okay, let's see, 4 radical 5, and this is one of those. So negative 4 and negative 1 is negative 5. And then square root of 5 times the square root of 5 is going to be 5, so that's going to be plus 5. Plus 5. So when I'm done, I get 9 minus 5 radical 5. Okay? Hopefully you see how that kind of looks like a it kind of looks like one of the binomials, right? Especially since this term in the end is the same. Okay. All right, so that's your answer there. Okay, so I just want to go back over this and remind you, when you are simplifying radicals, make sure you make that. Look first to see, is there a fraction underneath the radical? Okay, if that's true, you got to get rid of it. Then, is there a radical in the denominator? Okay, and if so, you have to rationalize the denominator. And then finally, make sure that there are no perfect squares underneath the radical. All right, so this is what I want you to do for exercise tonight. And again, don't log in. It's probably a good idea not to log in. And then to go ahead and go on these exercises. We've got simplifying radicals, multiplying radicals, and adding and subtracting radicals. So go ahead and do that. And then tomorrow in class, you'll have a chance to work on problems out of the book.